maybe just go over the questions of these, right? Because these are the questions that you didn't solve last time, right?
Yeah.
Yeah, just go over some of these questions. Mm, yeah, so something like 11.44. You can read it. It basically just says that you have a quadrilateral and you are given some ratios of the size. You see? Ratios of
Yeah.
the size. Yeah. So what is the smallest perimeter, possible perimeter? The key to this problem is that based on the ratios, you can suppose x. That means you can express every side with x, right?
Okay.
Yeah, after you express every side with x, you will see that x actually can be any number, any positive number. Okay, but the problem is in the question it says all the side lengths have to be integers, you see?
Yeah.
So if they're integers, then that means x has to be, say, a multiple of 5 and a multiple of 3. So that's why the smallest number is 15. It can be 30, it can be 45, okay? But you want the smallest possible perimeter. So x is 15.
Okay.
Yeah, so the key to this problem is to figure out these denominators, right? Using those ratios. So suppose x, get some denominators, and x has to be a multiple of all the denominators, that's the least common multiple, okay?
Okay.
Yeah. For this, I remember that you didn't solve it because you didn't realize when we do this, you basically just have 6 equilateral triangles, right?
Yes.
Yeah, and that's it. If they're all equilateral triangles, every side is equal, you can find the perimeter, right? Okay. In the
Okay.
next question, basically what you forgot is the exterior angle thing, okay? The sum of exterior angles, don't forget, is gonna be 360 degrees for any polygon, right? Do you remember this? For any polygon, the sum of exterior angles is 360 degrees. Okay, seems
Yeah.
like you. Uh-huh. The proof is this, but we have done the proof many times, okay? I'm not gonna do the proof today, but exterior angles means these, right? You know what
Yeah.
exterior, okay, yeah. The sum of exterior is always 360 degrees, right? Okay. And then in this case, in this question, basically Rebecca walks 100 feet and turn 20 degrees and 100 feet and 20 degrees, right? So this is diagram. And in the end, it just asks what is the perimeter she walks, right? Since each side is 100, basically we just need to figure out the number of sides, okay? To figure out a number of sides, this 360 divided by 20. Because, right, if each time she turns 20 degrees, then that means that 20 degrees is the exterior angle.
Oh, okay.
And the sum of exterior angles is 360, remember? So we'll do a division, 18 sides. Every side is 100, that's 1800. See,
Okay.
yeah? See if that makes sense? Yeah, so we're gonna learn to convert this 20 degrees into actually exterior angles, okay? And then use the sum of exterior angles divided by that. And this is a very common strategy when we have polygons, especially polygons with a lot of sides, and when you have exterior angles. You just do a division, and you can determine the number of sides. Okay?
Okay.
Okay, yeah. Um, what about this? Let's say we have a polygon with unknown size, okay? Unknown number of sides, like this, okay?
Sure.
Yeah. But let's say here we have an exterior angle. Let's say this is 9 degrees, okay? What is
Okay.
the number of sides of this polygon?
think x minus 2.
The exterior angle is 9 degrees. How many sides is the polygon?
I think the formula for the exterior angle is like x minus 2 times 360 over 180.
No, that's the interior
No,
angles. The sum, okay, again, the sum, what is the sum of exterior angles? We just reviewed.
uh,
Okay, 360 degrees.
360. Yeah.
Yeah,
So like 360 degrees divided by 9.
yeah. So 40 sides, right?
Okay.
Okay, make sense? Remember this, okay?
Yeah.
Sum of the exterior angles 360 divided by the exterior angle
Oh,
is the number of sides, right? Yeah, okay. Now we'll continue. So 11.47, well, this question, you're just gonna add some lines, and then basically there were just a bunch of quarter circles, semicircle, and stuff, okay? Shouldn't be too hard. You see the whole, this diagram should make sense, right? You just add some lines, quarter circles, and squares, okay? So there were a lot of similar questions like these. You will see these in AMC 8, AMC 10, AMC 12. You always add some lines and try to make them into some regular shapes, okay? Okay, 11.48 is mainly about the triangular inequality, okay? Triangular inequality. What is triangular inequality?
it's like if two sides add up to another, then it's like
It's greater than the other, right?
greater than yeah.
Yeah. So we say the sum of any two sides is greater than the third. Okay. And to be more specific, think about this. You don't know which two sides to add so that is greater than the other side, right? So that means you have to do three of them, right? Okay.
Yeah.
Yeah. And that means for many questions, if you do three, it can be confusing, can be hard, okay? However, if you are able to know which side is the longest, you only need to do one inequality, right? Because,
Yeah.
yeah, all you need to do is to make sure that the sum of the two shorter sides is greater than the longer side. Okay, so in this question, we didn't read the question, but in this question, it's basically like this. All three sides are like these, okay? So you are able to find the longer side. That means when you apply the triangular inequality, you do not need to apply three times. You only need to do one time. Two shorter sides add up should be greater than or equal to the longer side, okay?
Okay.
Make sense? Okay, then we'll continue, all right? 11.49, again, triangular inequality. This is a diagram. 8, 10, 12, 16. Okay? The question is asking, what can x be?
Okay.
Okay? Triangular inequality, you see? Because ABC is a triangle. ACD is also a triangle. For both triangles, well, this x has to satisfy the triangular inequality. Okay? Let's do this briefly, see if you can figure this out. If you look at triangle ABC, what are the possible values of x?
Then basically use
What
we could
is
use the triangle equality, which is AB plus BC is like greater than AC.
yeah? So what is the range of x? You just said
Uh,
it. 8 plus 10, right?
yeah.
That's what is that what does that mean to x? What is
Basically,
mm,
X is like less than 18.
Yeah, very good. And then
And then we could, and then from the other side,
Mhm.
like 28. No, x is less than 28.
That's the other side. Let's focus on ABC first, okay? Triangle ABC. X less than 18, correct, but not fully correct, okay? You're There's another part. It has to be greater than a number, right?
Yeah.
Yeah.
Oh, I think uh like since like B like BC plus AC is like, wait, no. Uh
What is the shortest side?
oh, AB.
No, 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 no. I mean, what is the shortest like the smallest value of x here? On the diagram, this is just a random diagram. It's not drawn to scale. Okay. So
Uh, uh,
you're not sure if x is greater than 8 or less than 8. Okay, it shouldn't take this much long.
I think it's like uh since I think is x
Okay.
2.
2, yeah. How did you figure out a 2?
Because I thought that like AB and AC, like which is 8 plus x, is like greater than 10. So
Yeah, exactly. Yeah. Okay. You don't have to, well, okay, Kevin, basically, if you add up the two sides, that's the maximum. If you minus them, that's a low minimum. That's it.
okay,
Why? Okay. Um, I mean, to understand triangular inequality, don't just focus on the letters, okay? Don't just say, okay, A plus B is greater than C, A plus C is greater than B, B plus C is greater than A. Yes, when you express them, it's like this, okay? But try to understand the idea behind this. Okay, what is the idea behind this? Remember that, let's say this. This is a triangle, right? So this is A, this is B, this is C. Obviously, A plus B is greater than C because if A plus B is equal to C, you're just gonna get this, right? A and B. Basically, all three sides are in on the same line, right?
okay,
Right? Right? So that means um the minimum condition for a triangle is basically that one side plus another is equal to the third, right? If one side plus another is equal to the third, so A plus B equals to C, that's like the minimum condition of a triangle, right? For a triangle, okay, when they're equal, right? So we'll go back here. That's why you do 8 plus 18,
okay,
right? Sorry, 8 plus 10, and that's 18, right? And that's why also you do 10 minus 8, because you want 2 here, because 2 and 8 and 10, that's that flat thing, right? 2 plus 8 is 10. If you put them together, it's going to be just a flat line, right? So it has to be greater than 2. Does it make sense? You add and you subtract. Does it make sense? All
yeah,
right. Does it make sense or no?
yes,
It makes sense? Yeah. 8 and 10, right? That was the question. 8 and 10. Obviously, the greatest is 18. And for the smallest, you want to put 10 here. 8 is here. Obviously, it's 2. So that's why you do plus and minus. Okay?
okay.
Yeah. All right. So that's in terms of triangle ABC. What about triangle ACD? In triangle ACD, what is the range of x?
Uh, so basically, like 4,
Mm-hmm.
no, x is greater than 4 and less than 28.
Good. So what are the values that it can be?
Like from 4 to 18.
Exactly, from 4 to 18. And it has to be an integer, right? So in the
Yeah,
end, it's going to be from 5, 6, all the way till 17, right? Okay, all of these are possible values for x. The question is asking how many different possible integer values. So that means you have to count the number of numbers here, right? Right?
yeah.
These are, yeah, how many are they? From 5 to 17. How many are they?
Uh, oh, they're like inclusive? No, uh,
What do you think? Don't
no,
ask, don't ask me if
no,
it
no.
is.
So, 13.
Yeah, good. So the answer is 13, right? Okay. Triangular inequality, all right?
Okay.
Yeah. And 1150 is like, yeah, basically some, yeah, we will see this in question in the future. So we don't need to be too worried about it. Um, if you use similar triangles, it's yeah, actually easier. Okay. All right. So we'll continue. We only have just 4 more chapters on this book, okay? This is pre-algebra, if you remember. This is mainly for AMC 8. That should be very fundamental. But we were actually doing books harder than these, if you remember, like algebra and
Yeah.
geometry, right? But we had some problems. I want to see if your fundamentals are good. Okay, so that's why we do this. Now, right triangles and quadrilaterals, here Pythagorean theorem. So the easiest proof of Pythagorean theorem, do you know that? This proof? Have you ever seen it? Do you know how to do it? To prove
Uh,
mm,
I think
Pythagorean.
I know.
You think you know? Okay. Can you explain to me? This is a diagram. How?
So basically, you assign like sides A, B, C.
Yeah, ABC, and then that's ABC.
Okay, and then so basically, uh, uh, like the C, which is the hypotenuse,
Mm-hmm.
is like a side of the square,
Yeah.
and there's like the square is an area of C squared.
Mm-hmm.
I mean, so basically, if
It is C squared. So good.
I think so, that proves that, I mean, every four of them are the same.
For
Wait, like,
okay.
mm,
So C squared is the area of the square, right?
yes.
WXYZ. Okay. And then how do we find the area of WXYZ using another way?
Uh,
That would be using the big square and subtract 4 triangles from it, right?
oh, yes.
Hmm. So what is the area of the bigger square?
The bigger square area is like C squared plus like the triangles.
No, 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 no. Okay. Um, okay, the key to prove Pythagorean theorem here is to find the area of WXYZ using 2 different ways. Okay. One way is, as you said, very simple, C squared. Okay. So this area is c squared. Let's write it here. WXYZ equals to c squared. What is it equal to in another way, right? We said that you're just gonna find PQRS and minus, well, 4 triangles. Are these 4 triangles the same?
Uh, yes.
Yeah, they're the same. Like this whole diagram is established by first drawing a right triangle and then rotate it here, rotate it here, rotate it here, right? Basically rotate it, right? You grab this, you can imagine, right? Just flip it over here, right? So of course they're the four triangles. So basically minus 4 times one of the triangle is the PWX, okay?
Yeah.
Yeah, so what is the area of the outer triangle, outer square? The area of the outer square. The outer square is just side times side, right?
Yes.
Yeah, so find the side. What is the side length of the outer square?
It is like A plus B.
Yes, because they're congruent triangles, right? This is B and this is A, right?
Yeah.
This is A, this is B. Yeah, so what is the area?
So the area is AB
AB,
squared.
AB,
No, AB times AB.
AB,
No, wait,
the side length.
like A plus B.
A plus B, right? It's A
Yeah.
plus B bracket squared, okay? All right, and a minus 4 triangles, right? What is the area of each triangle?
Uh, the area of each triangle is A, no, like A times B divided by 2.
Very good, okay? Can you open up brackets and simplify?
Uh, like A squared plus 2AB plus B squared minus 4AB, which is A squared plus B squared.
Yes, so it just becomes A squared plus B squared, right? See? They're equal. The area of the square, WXYZ, is C squared. And it is also this, which is A squared plus B squared. So we are able to prove the Pythagorean theorem, right?
Yeah.
Can it make sense? Did you learn this before?
Yes.
But you forgot partially. You,
Yeah,
you
partial.
remember? Yeah, remember partially. Yeah, okay, good. Not bad. Pythagorean triples. Remember what Pythagorean triples we learned in the past? Tell me,
Mm,
what are Pythagorean triples we learned? There were four sets of the most commonly used Pythagorean triples that you must know. Do you remember what Pythagorean triples are?
I think it's like A squared plus B squared plus C squared.
Yeah, that's the Pythagorean theorem. What are Pythagorean triples? Something like 3, 4, 5. Do you remember 3, 4, 5?
Oh, I think it's uh,
Mm.
like 3, 4, 5 is because 3 squared plus 4 squared equals 5 squared.
Yes. Then why are these three called Pythagorean triples? For example, 1, 1, root 2. 1 and 1 and root 2, right?
Yes,
Those satisfy Pythagorean theorem as well, but we don't call it Pythagorean triples. Why?
because I think there's must be
Three integers.
3 integers. Yeah.
Yes. Okay. There's three integers that satisfy Pythagorean triples. Sorry, that satisfy Pythagorean theorems are Pythagorean triples. Okay. Okay. So what Pythagorean triples do we have other than 3, 4, 5? Don't remember? Okay. Let's write it down again because it's many times. Okay. There's 3, 4, 5.
Oh,
There's
I think there's also 3, 4, 5. It's like uh
there's one started with 5. There's one started with 7 and 8. And our goal is to remember these four at
oh,
least.
I think it's like 941. No, wait.
Oh, that starts with 9. Yeah, that's another one. It's 9, 40, 41. Okay.
Okay. And then there's also 36.
But by the way, 9, 40, 41 is not that common. Okay, but I mean sometimes you can see it. But the most common ones are the first four. Okay. So if you
Okay.
start with the 5,
Oh, then
12,
5, 12, 13.
7,
7, 24, 25.
8,
8, 17,
yeah,
19.
15,
Wait. Oh,
17. Okay.
okay.
Yeah, just use anyway. Just remember these, okay? Yeah, at least the first four, but you already got the fifth one, so that's pretty good. Okay, you will see that I'm I'm arranging them based on how large the first number is. Okay, the shortest side is. Yeah, there were actually infinite groups, but anyways, these are Pythagorean triples, and they're very common. Okay,
Okay.
yeah, no problem. All right.
Yeah.
Um, what we said about Pythagorean triples is that not only that they satisfy Pythagorean theorem, but also any multiples of them will satisfy the Pythagorean theorem, right?
Yeah.
Okay, here. Could you do problem 12.6 for me? The
Is this
hypotenuse.
is this like 3 times 4?
Well, almost for the legs are 3 times 4 and 4 times 4. Yeah, times,
Oh,
yes. What is the hypotenuse?
do I think I can use wait, never mind.
You use Pythagorean triples. It should be 1 second.
Like like 3.
Okay, maybe doing an example. Again, any multiples of Pythagorean triples will satisfy Pythagorean theorems, right? But the Pythagorean theorem, do you remember this? You can actually get to prove it. Do you remember?
Yeah.
You think? Okay. Do you remember how to prove it? Like 3, 4, 5, 3 squared plus 4 squared equals to 5 squared. If you get a
Yeah.
multiple, 3n squared, 4n squared equals to 5n squared, right? You just open
Yeah.
up brackets, you will see. Open up brackets, you get 3 squared n squared, 4 squared n squared, 5 squared n squared, and you can cancel out the n squared, see? And they're equal.
Okay.
Okay? Yeah, any multiple would work. So here, I'm gonna do this, okay? The legs are 3 times 4, 4 times 4. Well, I see 3 and 4. Very good. That means the hypotenuse is 5. That's 4 times this, so the hypotenuse is 4 times 5 times 4, 20. Make sense?
Okay.
Yeah. Okay. What was question B? Question B, the hypotenuse of a
I
what? Mhm.
3, 4, 5. Wait,
Yeah, 3, 4, 5. So what is the hypotenuse?
25.
Yes, very good. Question C.
Uh, I think
You don't need
also
you don't
3,
need to
4,
count.
5.
Yeah. So
Like is
You
I
don't need to
think,
calculate. You don't
oh,
need to calculate.
25.
What?
Wait, no, 5 times 2011.
Yeah. Question D.
Uh, oh, 5 times 1000101.
5 over.
Oh yeah, 5
Mm,
oh.
good. 12.7. One leg is 210. Hypotenuse is 750. 210, 750. What do you do?
Maybe we could factor, like,
Mhm. Factor how?
like,
Do, and what is your idea? What is your thought before we start and talk about that?
I think maybe we could, like,
Do you think this question is related to the last question in some way?
yes, maybe you could do, like, a number times a number, or, like,
Yeah, very good, right? We want to see if 750 and 210 are both, say, some number times some number, right? And one of the numbers should be the same because it's going to be a multiple, right?
yeah,
Yeah. So like the other number, like in the last problem, like the 4, 5, or 2011, or this denominator, this thing. How do you find that number in this case?
probably we could, like, divide both by 5.
You can actually divide it both by 10. There were two zeros, right? In other
Yeah,
words, what are you looking for? Divide by zeros, and then you can divide by 3. You are looking for the greatest common factor, right?
yeah.
The greatest common factor here, okay? So what is the greatest common factor?
Uh, then, uh, like, 30,
30. So we have 30 times what?
30 times 7,
Hmm. The other one is th-
times 15.
15. Is 3 times what is 75?
3 times, oh wait, 25.
Yeah. Do we see Pythagorean triples? So the multiple is 30, right?
Yeah,
So the other side is 30 times a number. What is the other number?
the other number is 25, which is, I think,
7,
wait, 24.
yeah, 7, 24, 25. So the other side is just 30 times 24,
Yeah,
which is 720. You see? Make sense?
yeah,
Yeah, okay. Yeah, shouldn't be too hard, right?
yeah.
Um, there is let's see, let's do some star questions, okay? Still that thing, still that Pythagorean thing, okay?
Okay.
Mhm. This and this are legs, okay? What is the hypotenuse?
Mm,
Just like the question we just did, you're gonna
I
find,
think the greatest
yes,
common factor.
good. What is the greatest common factor?
Uh,
Just start with the easier one. We can immediately see what number is a factor.
Like I think 3. No, 9. Oh no. Wait.
Mm. Uh, they look very
7.
similar. Yeah, there's seven. Very good. It's 49 and 63, right? There's a seven. And also, what is a common factor? They look very much the same, right?
Yeah.
Very similar. So that means, I mean, just by looking at it, you should know what number times what number is this. Does that make sense?
Yeah.
Okay, let's start with some easy ones. Let's say 50005. That's very similar to this too, right? I'm just changing 49 to a 5, right? Okay. Can you see what a can you see, can you tell a factor of it? What is
Yeah.
yeah, what is the largest factor of this number?
Uh,
Come on, come on.
uh
You're two fives. So what
like
number?
one,
Mhm.
like
Yeah, yeah.
10001.
Yeah, times five, right?
Yeah.
Hmm. So what about these two? Okay, if it still doesn't make sense, let's say what about 90009?
Oh, then 10001.
Yeah, what about eight? You get what I mean here?
Yeah.
Yeah, so what are, mm, what are these two numbers?
Like 7000007.
Yeah, very good. Yes. So 10001 is also common factor among them, right? Between them. So the greatest common factor would be 70007, right? The first
Yeah.
number is actually just what number times that number?
Uh, times like not like same
49 times what?
7.
7. Good. Second number?
Uh, times 9.
Good. What is a hypotenuse?
Then it's uh 7 and 9.
7 and 9 are not Pythagorean triples, okay? So don't worry. Because if you start with 7, remember it's 7, 24, 25. Okay.
Okay.
But does it matter? If it's not Pythagorean triples, what do we
Like
do?
I could just do Pythagorean theorem.
Yeah, just apply Pythagorean theorem. So the hypotenuse is just 70007 times the Pythagorean theorem to the square root of 7 squared plus 9 squared. Make sense?
Yeah.
Yeah, so we just need to find the common factor, the greatest common factor. So this number, 70007, is a multiple here, and the actual three sides are these three, you see?
Okay.
Yeah, so you just find a small number, and you do a Pythagorean theorem here and times it by 70,007, okay? Make sense?
Yeah.
Okay, good. Is 7 your favorite number? Somehow have this impression. Do you like this number, 7?
Not really.
Not really,
I'm
okay.
sure.
Yeah, I somehow remember that you told me that. Okay, that's fine. Let's continue. Okay, in the next section, we're gonna learn two special right triangles. I'm not sure if you remember them, okay? Because we actually learned this in the past. in geometry and stuff, okay? So I'm gonna just give it to you what the first triangle is, okay? This is the first kind of special right triangle. Do you remember what is the ratio of the three sides? And you probably have learned this in your, I don't know, Kumon, whatever, math.
Oh,
Yeah,
like nine, like
yeah,
isosceles,
yeah. So that's what is the ratio of three sides?
or like one,
Mm-hmm. I heard one.
yeah,
Yeah,
one and root two.
very good. It should be very simple, right? Because it's isosceles. If it is isosceles, it's supposed to be one, supposed then the other side is also one. Pythagorean theorem root two. Done. Correct?
Yeah,
Yeah. Okay, so the ratio is just 1 to 1 to root 2. Okay, you can actually time it by any number you want, say x. So they can be any other numbers, but the ratio is always going to be 1 to 1 to root 2. Okay?
okay.
Yeah. What about the other spiritual triangle? Do you remember what the other spiritual triangle is? It's 90 and what degrees?
Root three.
30,
Oh,
60.
yeah.
Yeah, not 3, 30. Yeah. Okay, so what is the ratio?
Mm, then, uh,
You don't remember?
yeah,
Okay, and I don't think you remember the way either.
yeah,
Okay, let's talk about this. Um, that's like I remember this at least the third time. Okay, so when we do this, we flip it. Don't forget. Okay, flip it over this longer leg. When you flip like this, you get another triangle here, right? Reason we do that is because this is going to be 60 degrees. This is going to be 30 degrees. So this big triangle is an equilateral triangle. You see, 360 degrees.
okay.
Okay, does it remind you of anything? What's next? Okay, now that we have flipped it, we know that this side equals to this side, right? Correct?
Yeah,
Yeah, because you flip it, both, well, basically both triangles are congruent, right? Okay, so if they're equal, you can suppose this to be one, and that means this whole side is two, right? This whole side, and it's an equilateral triangle, so this is also two, this is also two. Make sense?
yeah,
Yeah, and with two and one Pythagorean theorem, 4 minus 1, 3, square root. So it's going to be, you see? So the ratio is 1 to root 3 to 2.
okay.
Okay, make sense? Does this ring a bell? Do you remember anything like these?
Yeah,
It was in the book Introduction to Geometry. Yeah, okay. Anyway, um, so for the first ratio, it's not hard to use it because both legs are the same, right? So it's very simple, okay? For the second ratio though, Kevin, this is very important. A
okay.
lot of students confuses between 1 and root 3. We said we actually well we talked about a way to remember this, but you probably forget already. Do you remember how to remember how to differentiate between these two? Okay, I think you forgot. So here, the 30-degree angle, okay? Always find the 30-degree angle. The when you find it, you go to the opposite side, and that's the so-called one. Okay? This one
Okay.
simply means it's half of the hypotenuse, right? Half the hypotenuse, correct? So we
Yeah.
say the side opposite to the 30-degree angle is half the hypotenuse. Okay? Why am I stressing this, Kevin? Because a lot of students, when they see this, they thought this is root 3 and thought this is 1. They're confused. They don't know which side is root 3 and which side is 1, right? Especially when you have different orientations, given like this. If this is 30 degrees, that's all you know. How do you know which side is root 3, which side is 1? That's a problem, right, Kevin, you see?
Yes.
Okay, so a lot of students they confuse. They confuse between them. But my way is that you always find a 30-degree angle, and opposite to it is 1. Hypotenuse is always 2. Hypotenuse you will know by finding the opposite side of the 90-degree angle, right? Once you have
Yeah.
1 and 2, Pythagorean theorem root 3. Make sense?
Yeah.
You can always remember this, right? So this is the way to memorize this so that you don't get it wrong, okay? 90-degree angle to here, hypotenuse. 30-degree angle, half of it.
Okay.
Mhm. Okay? And by the way, why is 30-degree angle opposite to 1 and 60-degree angle opposite to root 3? There is a very simple rule in triangle, which states that the larger the angle is, the longer the opposite side is. Okay? Let's say angle. Okay, in a triangle, if the
Okay.
angle is larger, then the opposite side length is longer. Okay?
Okay.
嗯，中文就说大角对大边，小角对小边，你有听过吗？Bigger angles to longer sides, okay, to longer opposite sides. Smaller angles, their opposite sides are shorter, okay? All right.
Yeah.
Yeah, so obviously for 30 degrees and 60 degrees, 30 degrees is a smaller angle, so the side opposite to it should be shorter, right? So for 1 and root 3, which number is smaller?
Uh, 1.
1 is smaller, right? Obviously. So see, smaller angle, 30 degrees, smaller side. Larger angle, larger side. Okay, larger angle is opposite to larger side. Okay, make sense?
Okay.
That's another way to remember this, okay? Just I don't care which way, but always remember 1 is the opposite side of the 30-degree angle. When you think about any geometry or in the future trigonometry question in your head, when you consider a question in your head, always remember 30 degree 1, 30 degree 1, okay?
Okay.
Yeah, let's try not to make this kind of error in the future, all right? Um, okay, so that's some special triangles, and we can use special triangles to do a lot of questions. Blah blah blah. Let's just do some exercises then. Okay, I think if you are familiar with this, these should be simple. Okay,
Okay.
yeah, missing sides. The missing side lengths. First diagram should be simple.
Yes.
Yeah.
8.
So yeah, 8. Good. Second diagram.
Uh, uh, 8. Wait.
8. 8 here, or what do you
Yeah.
mean? Hmm. Why do you think it's 8 here? Why is it 8?
Uh, because like it's 1 and then the ratio and then the one's 2, 3.
Mhm. But the problem is, so first of all, how do you know it's a special right triangle? Did it tell you is 39, 30, 60, 90? It didn't say it is 30, 60, 90, right? And
Yeah.
it doesn't look like one either. So, I mean, even if it looks like one, it doesn't matter if it's not labeled. You cannot assume that, okay? You see? If the angles are given, they will label it, okay? So in this
Okay.
case, you don't know if it is a special triangle or not. Okay? And even if we take a step back, Kevin, let's say this is a special right triangle. Still wouldn't be 8 though, right? Because the shorter side, remember, is half the hypotenuse. At least it's going to be 10, 20, 10. And this side is going to be 10 root 3, right?
Yeah.
That's a special triangle. And yeah, and the fact that this is not 10 root 3, the fact that this is actually 16, it tells you it's not a special right triangle, okay?
Okay.
Yeah. But I don't think it will matter. How can we find, say, MV? 20, 16, right? What do
Yeah.
we do? Multiple. Think about a multiple. Do you remember that we did some questions with the greatest common factor and stuff?
Yeah.
Yeah, that's what we do here, right? 20, 16. What do we do?
You like time,
What's that?
mm, times
Times what?
like I think the angles are wait. No,
It's not related. Okay, Kevin, just look at the triangle on the right. Triangle on the right, okay? 20, 16. Tell me, what is the other side? We just did this many, many times.
I think oh which 8. Hmm. I keep thinking 8, but it's not. So
It's not 8. So what do we do? Okay.
so there were 3 and 2.
Why does it take so long? Kevin, we just did this, remember? You see? The two legs are like these big numbers.
Oh
And
wait,
we
it's oh so I think wait, it's finding the hypotenuse. Wait, no.
just the leg.
Oh, so basically, is it just like 16 equals like 8 times 2 and
Mhm.
then 20 equals 10 times 2?
But okay, yeah, sure. 10 times 2, 8 times 2, right?
Yeah.
And then,
Then
is that it? 8 and 10, is
no.
that it?
No, I think like we use the Pythagorean theorem.
Yes, we
Like
do use the Pythagorean theorem, but before you apply the Pythagorean theorem, when you see 20 and 16, what do? Remember that? Okay, let's go back to this question again. What did we do here? What did we do here?
we apply the like we find the greatest common factor.
Yes, we find a greatest common factor. Remember, we did, see, we just did two questions, remember? Okay, so, um, Kevin, the problem is that when we talk about this, you know you're gonna do this, right? Just
Yeah,
after a while, we talk about something else and you forgot we're gonna do this, right? So you're gonna it doesn't matter where we talk about it, right? We're like where the question is. When you see this kind of question, especially when you see, okay, 16, 20, they're both even numbers or not. You want to find the greatest common factor, right? Always
okay.
remember, it doesn't matter if they're Pythagorean triples or not, okay? Even if they're not Pythagorean triples, you can always find the greatest common factor, divide by that, and just use the smallest number to do Pythagorean theorem, and then time the number back, right? Okay,
Yeah,
and that will reduce the amount of calculation you need to do because here, if you these numbers are fine, but what if say it's big numbers like I don't know 2200 and 160, right? If you still do Pythagorean theorem directly, it's gonna be really hard, right? Because the numbers are really big. Okay, so we
okay.
use yeah multiples. What is the greatest common factor here?
So basically it's four,
Yeah, so it's 4 times 5, 4 times 4,
and then
3 times
and then
4, 12.
three,
Here
four,
we go.
12.
You see? Pythagorean
Oh,
triples, right? So find the greatest common factor so that you can lower both sides down to, down to a smallest number. So 4 and 5 here, okay? And we'll see 4 and 5, the other number is 3 times the 4 back, that's 12. Does it make sense now, Kevin?
yeah.
Okay, good. Continue. So now we know this is 12. We're gonna label all the missing sides, right? So we have a 12. What about the other missing sides?
I think it's the same.
Yeah, it is the same. So that's 12. And the other
And
T. Mhm.
like 20 and 16.
Yeah, 20 and 12, right? Okay. Make sense? Make sense?
Yeah.
Yeah, okay. Next. Missing sides.
Then we could first split it into like a rectangle and yeah, and
Good.
then
Very good.
90 degrees and 30 degrees. Like
Mhm.
120 could be split into 90 degrees and 30 degrees.
Yeah, yeah. Very nice. Okay, yes. Good. And then?
And then basically, so since there's a 14, and then
I'm gonna label this. What side do we know now? Just look at the special right triangle, right?
yeah,
hmm
triangles. So like one which is I think QT is 7.
Very good. How did you know?
because the ratio.
Because of the ratio. How do you know that the QD is the ratio is 1, not root 3?
Uh, because of three, like
Well, I just want to see if you remember how to find that one side. Remember what I just told you?
yeah. So it's mm, like there's like 30
Yeah,
degrees,
very good. Yes,
and then
very
yeah.
nice. Yes, 30 degrees. So half of the hypotenuse is 7. Very good. Okay. The side opposite to the 30-degree angle is half of the hypotenuse. Okay. Always
Okay.
remember this, and you say this. You say this. Okay. It's not like just some random thing I give to you or any other teacher give to you. This is something you can always use, even if like you are grade 12. Okay. In grade 12, you still do this. Okay. Because even in grade 12, some students they confuse between 1 and root 3. So you always remember this 30-degree angle, 1 half. Okay.
Okay.
Continue. Yeah, very good. Continue.
Then basically seven, and then we can use the Pythagorean.
No
Wait,
triple is
no,
special right triangle.
just theorem.
Yeah, special right triangle. No theorem either. Okay, no theorem, no triples. Just ratio, remember? Remember
Then
ratio?
root three.
Yeah, 1 to root 3, right? So basically
Yeah.
just time by root 3. So what is PT?
So PD is like root three.
Just
No,
root just root
like
3?
root
Okay.
three like times. No wait.
The ratio, Kevin, ratio is 1 to root 3 to 2. The actual
Seven
length,
to root three. Like
yeah,
seven.
7 root
Wait,
3, right? It's just
yeah.
7 times the ratio. Okay. So the so-called ratio, okay, again, 1 root 3, 2. The so-called ratio is simply that the hypotenuse is twice this side. That's why it's 1 to 2, right? The
Okay.
longer leg is just root 3 times the shorter leg. In other words, the leg that's opposite to the 60-degree angle is root 3 times the side that's opposite to the 30-degree angle. That's what it means by 1 to root 3, right?
Yeah.
Okay, that makes sense? So that's 7 root 3, okay? So it's kind of immediate, okay? So 7 root 3 here. In the end, what about PS and TR? I think you didn't probably didn't see this. There's a bar here, see? Okay, see? Bar, bar.
Okay.
So that's 14. That means this side is 14. That means this is 7, okay?
Okay.
Yeah. I think you didn't see it, but yeah, that's simple, okay? Yeah, I just want you to know this, okay? Use the ratio thing.
Okay.
Yeah. Mm, let's do this 2.4, which is from AMC 8, right? Base of an isosceles triangle is 24 and area is 60.
I mean, isn't like area like base times height, or if we already know the base, like the height is five.
Good.
Wait, no, wait, no, it's
It
wait,
is, it is,
oh,
right? Base 24, height is 5, the area is 60, right? And
yeah,
then, and then
uh,
we wanna
oh,
find the legs.
and then so basically, since it is an isosceles triangle,
hmm
uh, we could deduce that like one and root two, like the ratio.
No. Okay. Um, the so-called the 1:1 ratio is only for isosceles right triangles. This is just an
Oh,
isosceles triangle. It didn't say right triangle. Okay? So you can't just use the ratio there. Okay, I guess we just Okay, again, you see, it's 1, 1, root 2. Right triangle. Not only just isosceles, but right triangle, okay? In this question, did it say is an right is an isosceles right triangle?
No.
It didn't say, right? Okay, so we draw this diagram like this. Height is 5, base is 24, okay?
Okay.
What is the question trying to ask?
Like, what's the length of AB?
Very good. How do you find AB?
Oh, well, I mean, like CB, like the midpoint is like, yeah. And then MB is 12. And then I think, yeah, it's 13.
Yeah, there we go. You see, Pythagorean triples. Yeah, very good. Okay, isosceles triangle. If you have a altitude, then the altitude bisects the base, right? Remember?
Yeah.
Yeah, congruent triangles and stuff. Okay. Yeah, very nice. Okay, let's just keep going. So quadrilaterals, there were. Do you still remember all different shapes, all different types of quadrilaterals? I think you still remember, right? Square, rectangle, whatever,
Yeah.
right? Yeah. Just there's just one special thing, which is a rhombus. Do you remember what a rhombus is?
Yes.
Okay, what is a rhombus?
A rhombus is like, I think
Mhm.
it's like all four sides are the same.
Very
It's
good.
like a square, but like flip. No, like not flip, but like a diamond shape.
Yes, very good. Like a diamond. So all four sides are equal, right? Like this. So a square is a special rhombus, right? A rhombus with 90-degree angles is a square. So a square is a special rhombus, okay? Make sense? Make sense?
Yeah.
Yeah, okay. How do you find the area of a rhombus?
Uh, since all sides are the same, it's just wait, is all sides are the same? I'm not wait, yeah, it is.
That's the definition of a rhombus, right? So all four
Yeah,
sides are
and then
equal.
so like to find the area is just like one side times one side.
No,
Wait,
no. One side times one side is for 90 degrees, okay? Like a square is
oh
90
wait,
degree, or a
so I think
rectangle.
we can
Remember that, say, for a parallelogram, when you find the area, you don't just do side times side, right? You're gonna
oh
find
it's
an a
height.
height and base times height, right?
Yes.
But in rhombus is very special. You don't remember?
It's like
It's related to this diagonals. Do you remember?
wait, so basically you split into four triangles
Yeah.
and then
Okay. It seems like you don't remember, but the formula is just that you time the diagonals and divide by 2. That's the area for a rhombus. Okay? The reason why is, well, it's actually pretty simple. So, there are many ways to get this, but the easiest way to get this is that you just change this triangle, put it over here. See? You put this triangle over here, right? So that means you basically just have, you see, a rectangle. Okay? And for this rectangle, the length is BD. The width is just half of AC, you see? Half of AC. That's it. BD times AC divided by 2.
okay.
Yeah. But there were many other ways to get the same formula. I don't want to delve into detail. Just remember this, okay? This is pretty fundamental. This is like, how long have we been having classes? This is like in COVID, we were doing geometry. I already covered this, okay?
Oh,
So
okay.
yeah, diagonal times diagonal divided by 2. Yeah, this is more of a review. Like this whole book is a review for you because um except chapter 14 and 13, I think only except maybe yeah part of 13 and 14, every other things you have learned. Okay, just a few things you didn't learn. Yeah. Anyway, so parallelogram, base times height. What else? Nothing else. Right? Nothing. No more. Let's try to do these. Make sure you understand what is the area here. All of these are very simple. Okay.
Okay.
No, part A. Hmm?
I think
Okay.
uh uh, uh 36. Wait, no, wait. Uh so basically uh eight. So the area of the triangle is 4, but
Okay. Think about B, C, D. And I need to go to washroom again. When I come back, I'm gonna go through these for you. Okay. Think
okay,
about B, C, D. Yeah. Finish them.
okay.
All right. Anything you have figured out?
I think we can like calculate the small triangle and then
You're still working on part A?
wait. Oh wait.
Okay.
I'll also like start working on like part B and
O-
C.
Okay. Let's just discuss part A. In part A, um, if you find that smaller triangle, what's next?
The other, which basically
Yeah, and you're gonna do this too, right?
yes,
Uh, Do you think it's possible?
no.
That's yeah. So let me ask you, what kind of shape is part A? What is this shape?
It's like a like a undefined one.
No, it's a
Wait,
trapezoid. This is a trapezoid. Why is it a trapezoid?
wait,
You didn't see it? What is the
I
definition of a trapezoid? Do you remember? Okay.
oh wait, one like there's one parallel like
Yeah, exactly. You remember that like in the very beginning of geometry, there was one class, it was really, really long time ago, like the basically after your SACT. Okay. I there was guide. I guided you through all the quadrilaterals, right? And we started with any quadrilateral, just a random one. But if you have one pair of parallels, you're gonna have a trapezoid. Normally, the trapezoid looks like this, one side like this, right?
Yeah.
But it can be something like this. It can be something like one side is like this, the other side is like this, something like this. Doesn't matter as long as you have two parallel lines or pair of parallels, okay? One pair of parallel is a trapezoid. Two pairs of parallel is a parallelogram, okay?
Okay.
Yeah. So if this is a trapezoid, how do you find the area of it?
Uh, then it's like base times, wait, no, like 7 plus 9
Mm-hmm. And then,
divided by 2.
and then,
Wait,
yeah, 7 plus 9 divided by
I
2, and
think I
then
think times a number, but
times 4.
oh, okay.
4 is the altitude, right?
Yeah.
Yeah. Do you recognize that 4 is the altitude? Because of this, right? Because of this perpendicular. This part is perpendicular to the base, so that's why it's the altitude, right? Okay, so so the sum of the bases times altitude or height divided by 2. Does it make sense or not? Do you remember how we
Okay.
get this? We get this by simply drawing a diagonal, okay? Something like this. You see?
Okay.
If you draw a diagonal, you have two triangles. This 6 actually is useless, all right? Triangle ABD, 9 times 4 over 2, right? The other triangle, 7 times 4 over 2, see? Because it has the
Yeah.
same height, right? So this height is the height of that triangle. So that's why it's also the height for the entire quadrilateral, okay? And if you add them, you will see that 4 over 2 is the common factor, so you get 7 plus 9, see? So that's why it's the sum of the bases times altitude divided by 2, okay? For any trapezoid. Does it make sense now?
Yeah.
You see, this trapezoid is just divided into two triangles, right? This is the altitude, top base, bottom base. So A times H divided by 2 plus B times H divided by 2. That's just A plus B times H divided by 2, okay?
Okay.
Yeah, all right. Okay, I'm very glad that we did this. I thought this should be very simple to you. Part B.
So since H, it's this is a parallelogram.
Mm-hmm. Yeah, it is a parallelogram. What is the area, the formula for the area of a parallelogram?
Uh, like height times base.
Yeah, base times height. Good. Do you have
So
a base and height
30.
here?
So it's 30.
30. Very good. What if I want you to find this length? What is the length of that blue thing?
Uh, uh,
Do you know the reason why I ask about this line?
No.
No, okay. Well, with this perpendicular thing, what does it mean? What is the special meaning or the significance of this blue line to this parallelogram?
It's like also another height.
Good is a height for the other base, 8, right?
Yeah.
Okay, so you know the area is 30. You know the base is 8. What is this height? No idea.
I think
Mhm. Okay, 8 times this altitude, this blue altitude, should be what?
uh I think 8 times this altitude should be 30.
Yeah, so what is this altitude?
Like 3 point
No, no, give me fractions, remember?
oh uh so 30 divided by 8.
Yeah, 30 over 8, so
So just simplify it.
yeah, simplify. What is it?
Oh 3 and then 6 over no 3 2 over 3. Oh wait, so you like 30 over 8, which is 15 over 4.
Yeah, what, why do you get something else? I don't.
Like I thought it was like you put like a number 3 and then like in the fraction.
Okay, I don't know, but it's 30 over 8 is 15 over 4. Okay, shouldn't take too much time. Okay, Kevin, make sense? So from this example, I want to let you know that when we are working on the same shape, we are working on the same area, we can always do base times height equals to the another base another times another height. So you can find missing height or missing bases. Okay?
Okay.
Which is a very important idea, all right? Using the same area and stuff. Okay, part C. Part C.
I think it's a rhombus.
It is a rhombus.
I mean, so basically, it's the exponential. Uh, we could split it down the middle and then 6. Oh,
Mhm.
base 7 times. Wait, 7 times 6. Divided by. Wait,
Okay, this is a rhombus. Yes, we did say that the area is the product of the diagonals and divided by 2, right? But in this question, the diagonals are not given. So obviously you don't go with this, right?
yeah,
Then what do you go with? Any other way to find the area? Saying that, okay, the area of a rhombus is the product of diagonals divided by 2 doesn't prevent you to find this area using other ways, right? What is the other way? Well, rhombus is what? Rhombus is also what quadrilateral? What kind of quadrilateral?
like no,
A parallelogram,
yeah,
right? It is a parallelogram. That means you can still use base times height, right? Base times height always stands.
okay.
Okay. Okay. So base times height.
like uh 42.
Yeah, 42, right? So
Yeah,
base is 7 because all four sides are the same. So this is 7, this 6 is the height. Done. Make sense?
yeah.
Yeah, okay, good. It's not that that's not that hard, okay, this?
Uh, it's like a rhombus. No. Oh wait, so maybe we could just like solve both triangles.
Yeah.
Uh, so basically,
So,
uh,
what is the difficulty you're having now?
I mean, I'm just trying to see if there's a triple. Like,
Yeah,
wait, no,
there were a lot of triples.
like a Pythagorean triple.
Yeah, there were Pythagorean triples. Do you see it?
13 and 15. Wait,
But 13 and 15, they're not right triangles. So before you find any Pythagorean triples, what you do here?
oh, maybe we could like W and Y make a
Exactly,
line.
right? You have to make a line. Very good. Because why do you want to make a line? Think about this. You said you want to solve for both triangles individually, right? So you say
Yeah,
that you want to find the area of WXZ, then obviously you're going to draw a height. The base is 24, draw a height here, right? For the other triangle, the height is also from Y. So basically just connect W and Y. Okay?
okay.
And then, yes, this is O. What's next?
And then we could do two since like 24 is the midpoint.
Yeah,
It's
because
12
it's,
and
yeah.
12 and like 12, 13, and 5. Like so W O is 5.
Mhm.
And then basically we could calculate Z W Y Z. No, I mean X Y no X W Z.
Yeah, we can do that later. We have another altitude to figure out,
And
right?
then since it's 5, and then I mean since there's no triple for
So what is OY? Still waiting.
uh uh 10.
10.
Wait,
It's not hard. Greatest common factor. What is it?
3 and then 3, 4,
Yeah.
9.
Yeah. Okay, what took so long?
Wait,
I'm confused because I don't see any
what I
reason.
mean, I thought it was like I kept thinking there was like a triple.
What was it? What's that? Okay, Kevin, I'm just saying that I don't see a reason why it takes so long, okay? Because we have done this 3 times already today, right? Same things.
Okay,
Greatest common
okay,
factor, right? Greatest common factor, not only 3 times, actually including that exercise, 6 times already, okay? So
wait.
divided by three, right? Common factor divided by three,
Oh,
five, four,
okay.
three, 5, 4, 3, 3 times 3, 9. Find the greatest common factor. That's the only thing you need to do. Find the greatest common factor, determine the so-called, well, the base number, right? The base, the lowest number, and use Pythagorean triples or theorem. Okay, and then find the area you will know how to do. Okay,
Oh,
make
okay.
sense?
Yes.
Okay. Mm, quadrilaterals. So, yeah, maybe I'll just leave this for your homework. Summary, that's the summary. Let's just do maybe some hard questions and I hope that can give you better ideas of what to do. Maybe let's just look at the hardest one. Yeah, let's just start with the hardest one, okay? You can read it and then see if you have any idea. When you're done reading, let me know.
Um, okay.
Mhm.
Senior
To work out this question, you need to know how to find, say, the length of a chord, or the area. So basically, you need to know how to find, say, the length here, or the area here, or the area here. Okay, we
Okay.
have done this before. But I'm not sure if you still remember. Okay, do you think you are able to, say, find the area here, or the area of a sector?
I think I can find an area of a chord.
Okay, good. Yeah, let's give it a try. So there's no number given. Of course, you start with, say, the radius is r. Okay, I'm gonna start for you. I'm not sure if you know that's the beginning part. Okay, since there's no number given, of course you start with some letters, right? You just say the radius is r. Okay, we want to show it. The Lewin has the same area as the isosceles right triangle, which is the triangle here. So they say OAB, right?
Okay.
Mhm. So basically, you just need to use this radius to find the area of the right triangle and also to find the area of the Lewin. Okay?
Okay.
What do we do?
Um,
No idea at all. It's just any idea, let me know, right? We discuss, mm, there were many, many things we just learned today, please.
I mean, first we could calculate like, wait, no, first we could say that like the triangle area,
Yeah, of course, yeah. So what is the area of the triangle?
like R root two, uh, like R, like root two times, uh, the height, which is R root two divided by two, uh,
Why is it so weird? Why? So you're gonna do this? Like root 2r and root 2 over 2r? Is that something you just did? Okay, no, I don't get it. Is it? Is it or no? Because you said root 2 and root 2 over 2. I know that AB is root 2. I know this is root 2 over 2, but if that's not what you meant. Okay, the area of AOB is very, 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 very simple, Kevin.
oh,
Just
it's,
right triangle. What do we do?
oh wait, I think Pythagorean theorem,
Pythagorean
like
theorem.
R and like,
Okay, maybe I'll
wait,
do this.
no.
Okay.
Oh my, it's like R times R divided by two.
Yeah, R times R divided by 2. What makes it so hard? It's a right triangle. Well, the go-to way is always to do leg times leg divided by 2, right? If it doesn't work, then maybe we can use the hypotenuse and draw another leg. Actually, draw another altitude, right? But this is a circle, so AO is also radius. Right triangle, R times R divided by R squared over 2, okay?
Okay,
Yeah. Now we try to find the area of the Lewin. How do we find it?
uh, then basically we could find the area of the chord, which is AB, like,
The area of the what? Of this sector or this
yes.
segment? Sector or segment? All right, Kevin. I think maybe when we are discussing a question in the future, I want to do this. Goal means analysis, okay? Basically, you tell me what your goal is and tell me what is the means you can get to that goal. Tell me the way, okay? So I want two things. What do you want and how do you get it? Okay?
You
Tell
want
me
like
what do
area
Mhm.
of the shaded
You
region?
want the area of the shade. How do you get it? Any idea?
I think you can get it by like calculating the semicircle and then subtracting the like area, like the, yeah,
Yeah, this part is called a segment, okay?
like,
Yeah. Do you remember all these words? Circle, right? A line touches it, it's called what? A line touches a circle is called tangent,
okay,
right?
and
The tangent line, right? The point of tangency, right? Okay? A line cuts through it is called a secant, remember? Secant, okay? If you only take the line segment, so something like this, with not a line, just a line segment, it's called a chord, right? Okay? If you have two radii, that's called a sector, right? Sector. And you connect this, you have a chord, and this little part is called a circular segment. Does it make sense? Segment, whole thing is sector, tangent, secant, chord. Any question about these words?
No.
Okay, very good. That was a good idea. So we know that so the area of the luen is the area of the semicircle, so the semicircle AB, minus the area of the segment, right? Good, let's just find them one by one. What is the area of this semicircle?
The area of the semicircle is basically the circle times no, like the circle divided by 2.
Yeah, how do we find the area of that circle then?
I mean, does this circle go through the midpoint?
Oh, I
Or
don't know, you're gonna tell me.
I think so.
It's hard to say. It's not
Uh,
about whether you think so or not, right? You have to prove it. But why bother? Don't bother, okay? Because you're just looking for the circle. Okay, as you just said, you want the area of the circle, right? How do you find the area of the circle? Goal means, right? Your goal is to find the area of the circle. Means, what is the way to find it? What is the formula for the area of a circle?
uh, pi 2 pi r squared.
2 pi r squared?
Wait, no, pi r squared.
Pi r squared. 2 pi r is the circumference, okay?
Okay.
Yeah. So that means you're gonna find what?
Then
The radius, right? You wanna find the area of the circle? You need to find the radius. I think it goes without saying, right?
yeah.
Right? Is it? Okay. So to find the area of the circle, say AB, I don't know if it goes through O or not, doesn't matter. You want to find the radius, okay? What is the radius? On the diagram, can you see it? Do you see any radius or diameter on the on this diagram for circle AB?
Mm,
It's literally one diameter right here, right in our face. Where is it? What is the diameter or radius of this circle? Which line? I'm
R.
asking which line.
Wait, the diameter is like AB.
AB, right? Didn't you see it before? Or
So it's basically like R root 2.
yeah,
Wait, or
AB is root 2R, and that's the diameter of the circle, you see?
okay.
Right? Okay, so yeah. So what is the radius? What is the area? What is the radius?
Uh, and then so the radius is root 2 R divided by 2.
Yeah, very good. Root 2R divided by 2. Sorry. Root 2 over 2R. Okay, that's the radius, you see?
Okay.
Yeah? So how do we find the area of that semicircle? We have the radius. Kevin, come on, fast.
Oh,
We
oh,
already know the radius for this circle.
so like pi times like 1/2 r squared.
1/2 r squared. So, I mean, √2/2r bracket squared, right? Yeah, when you open up brackets, it is 1/2r squared. Make sure we're on the same page. Are we on the same page?
Yeah,
Okay, good. Is that just it?
yeah. I mean, I just simplified it.
Okay, but there's
But
another 1/2, right?
yeah,
There's another 1/2.
so
Do you
times
see?
2.
No, 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 no. There's another 1/2. It's a half of a circle. Okay, so it's a half of pi r squared. What is r? R is √2/2r.
Yeah,
It's gonna be this, right?
okay.
Okay, if that makes sense. Okay, good. So yeah, we can calculate this. This is what? This is 1/4 pi r squared, right? Okay.
Okay.
Yeah. All right. Then we're gonna find a segment, correct? How do we find the area of the segment?
The area of a segment is, I remember the formula, which is,
Really? There's a formula?
wait, I thought you said a chord.
Cor- No, the segment. Okay, this area, right? You know it. Semicircle minus this area, right? How do we find this area? This area, right?
Um,
Maybe forget about this diagram. Just look at this. What we had was a right triangle, R and R, right? Like this. This is √r, right? We're gonna find this area, correct?
yeah,
Okay, how?
I think we can, like, since it's not a full circle, then
Okay, if you don't remember, we have done this many times before, okay? To find a segment, we're gonna first find the area of the sector and then subtract a triangle from it. It's not that hard, right, to see because if you just want to find the area of the segment directly, there's obviously no way, right? Okay, so it has to be a difference or a sum of something, and it's not hard to think that we're gonna use a sector and subtract this triangle from it, right?
okay,
Okay, okay, okay.
okay,
Yeah, so the segment is the sector AOB minus the triangle AOB. See if that makes sense? No, hello? Does it make sense? No?
yes.
Oh, makes sense? Okay, what is the area of the sector AOB? Sector AOB. How do you find the area of a sector?
Mm, I think it's just like a formula, like basically the angle, wait,
That's about the angle.
the
Instead of,
360,
if you forget the formula, instead of recalling the formula from your head, maybe try to deduce it. It's not hard, okay? Especially when you consider the fact that you have a right angle here. A sector is just part of the circle, right? The question is, how much of a part? This sector is how much of this circle? How big a part of this circle? It's a right angle. A right angle in the middle, Kevin.
Okay.
Right? Okay.
So 360. No, there's like you divide by 4, and then if you draw like a line from the corner of
Yeah. It's 1/4 of a circle, right? This is
yes,
not hard at all, right? See? Quarter circle. Half circle, quarter circle, right? Right angle, quarter circle. Okay?
okay,
Yeah. So let's do it. So what is the area of sector A will be?
then a quarter is like 1/4 pi or
Yeah, one out of four what?
pi r squared.
Yeah, very good, right? Minus what?
Minus I think like there's no minus because it's already been in 4. Like it's already
Okay,
divided by
yeah. The sector A will be is this, right? But you're gonna subtract a triangle from it. So I'm gonna,
so minus
yeah,
like uh minus like r squared divided by 2.
yeah. There we go. The area of the sector is this, segment is this, right? Does it make sense?
Okay,
Sector, quarter circle, right? Area of the triangle, we did it before. It's very simple, right? Just the quarter circle thing, okay? Because it's 90 degrees, it's very simple. If it is not 90 degrees, if you remember, whatever the degree is in the middle, let's say theta, you just do theta over 360 degrees, right? This allows you to find the proportion. Just use the proportion times pi r squared, you will get the area of the sector. Make sense?
okay,
Yeah, okay, so this is the area of the segment. Let's put it back here, correct? So put it back here, put a bracket on, okay? So now we can find the area of the Lewin, right? Right? No? Right?
okay.
Can you find it for me?
Oh, so the segment. Oh,
Yeah, oh, what? Just calculate, come on. See? I already calculated the first part, just open up brackets.
yeah.
Yeah,
That and then like minus no r squared. No, no, not minus, but like r squared 2. Wait.
what are you hesitating about? Over? What are you hesitating over? I don't, just open up brackets, you get r squared over 2, right? You just get this, right?
Uh, yes.
Yeah, so the answer is r squared over 2, correct? Okay, the area of the Lewin is r squared over 2, right?
Okay.
Does it make sense? Does it make sense?
Yes.
Yeah, okay. And the triangle is also r squared over 2, so they're equal. Yeah, that's done. See? We have shown that the Lewin has the same area as the right triangle. Okay?
Okay.
Yeah. So this question, you could say is hard, but it is also easy at the same time. Why is it hard? Well, it does use a lot of knowledge that we learned before, right? It's a combination of many pieces of many pieces of knowledge, okay, many pieces of facts. So yeah, so it's hard in that way, but it's also easy because if you really understand all these formulas, it's there's nothing hard because you don't need to add a line. It's very mechanical, you could say, right? First, you find the triangle. It's a right triangle. Everyone should know you do leg times leg divided by 2. It's mechanical. Okay? When you find the luen, when you see this luen, obviously you can only do semicircle minus the segment. There's really no other way to think about it, right? And for the semicircle is half of the area of the circle. You just need to find the radius. And to find the radius, you use special right triangle, right? You just use special right triangle, you can find the radius. Then you can find the area of the semicircle. To find a segment, quarter circle minus the triangle. Quarter circle just 1/4. That's it. I really don't see anything hard because in this question, everything is just all about the knowledge we learned. You don't need
Oh,
to be creative,
wait.
you see. Hmm? What?
Oh, nothing. I just like finally understood that. Like, yeah.
Yeah, understand what? What did you just understand?
I mean that like I use like prior knowledge of the circle. So like I divided a segment, no, like a quarter, which is 1/4 pi r squared. And then yeah, I just minus the like the triangle.
Yeah, exactly.
And I
Yeah.
get the like segment.
Yeah, this is a triangle. Yeah, the segment, right? The segment we did it separately here, remember? Right? Sector minus a triangle. Yeah. Okay. Kevin, the hard geometric questions are questions that you have to add some lines by yourself. You have to be creative. You have to try something. That's hard because you will never know what you try is gonna work. Okay? But question like these, even though yeah, it does have a star here, whatever, but it's not hard at all. Throughout, you don't need to add any lines. You don't need to try any of your ideas. I mean, there's only one idea. Okay, most geometric questions, especially in AMC 10 and above, well, when you look at it, you might have multiple ideas going on at one time because the shape is very um ambiguous, you could say. It's very ambiguous in terms of what line to use or what side to use or what area to use, whatever. Okay, it can be very hard. So you need to add some lines, sometimes even outside of the graph. So it's very hard. Okay, for questions like these, it's just some you know facts that we learn. Okay, so try to be familiar with this kind of question. Okay, in this book, I do expect you to figure out all the problems because this book is not hard. This book is especially consider that you have done a geometry book for like 5 chapters. So, okay, most of these are pretty easy. You don't need to add a line or just add a simple line. You can work it out. Okay. Yeah. So yeah. So today is more of a review, Kevin. Okay. So, yeah, just go over the stuff we learned today. If you forgot those quadrilaterals, whatever, you can Google them. Or I don't think you have the notes we had before. That was like 2 years ago, but doesn't matter. Just Google online is very simple. A lot of web pages explain it. If you need to see, okay, or you can just ask me. Okay, so review all the geometry facts you learned and memorize them. Okay, that's it. So your homework is to do chapter 12, I think, right? So chapter 11, we have already done it, right? Okay, so just do chapter 12, review, challenge, and maybe yeah, maybe it's just skip exercises, okay? Just do review and challenge is fine. Okay, Kevin? Yeah. For chapter 13, I just want to ask, have you learned these before? Like average, median, mode?
Yes.
Yeah, okay. So you know these. You just that's SSAT, right?
Yeah.
Yeah. Yeah, okay, got a mode and okay, that's some very basic statistics. Okay. Okay. Yeah, so chapter 13 will be easy. So if you have time, you can actually preview it and do some questions. This should be easy to you, okay? The only thing I think you shouldn't know, you should have problem with is chapter 14. The chapter 14 is about accounting. We haven't really delved into accounting that much yet, okay? But I don't think you should have a problem in other chapters, okay? So do chapter 12. If you have time, you can work on some chapter 13 questions as well, all right? Next time we're gonna just basically just go over chapter 13, maybe 20 minutes, and then we're gonna go to chapter 14, and that's basically the end of this book, okay?